So this is my circuit for the robot arm, and I broke the circuit down into about 6 or 7 parts just to make it simpler to work with and design and allow for modularity and abstraction. So this is the circuit, and to begin with, I'm just going to briefly go over every single component that I designed. So this is the synchronization edge detection part, and as we can see, it has a pH and QT inputs, and outputs are direction step, and also takes in the clock in order for synchronization. So let's say I give the pH a value of 1. Now we can see that it detected the edge, and we can see the rise. This also works, and you can see synchronize to the clock and gives out output for direction. Now let's go on to the register file, and as you can see, we have a demultiplexer for registers and then a mux over here with the select, data in, clock, reset, read write switch, and a data output, and this allows us to write and read data. So let's say I have it set to 0, and my data is 1 1, which is 3, and my select is 0, so I want it to be in this register. With the rising and falling of the clock, now that 3 is in here, now I can go put maybe put 5 in the second register, and as you can see, we put it in there. And if I change write to read, and now I can get the data out. So if I go to 0, I get the data at 0. If I go to 1, I get the data at 1, which is correct. Now going back to the circuit, so the next thing to talk about would be the position counter. And what this is just a simple circuit to keep track of what stage the circuit's currently at. And as we can see, so we have 4 positions, 0, 1, 2, 3 in playback mode, and the action allows us to increment when we're not in playback, and this disable allows us to disable the action button when we're in playback mode. The up is used to increment the circuit when we're in playback mode and we just want to go to the next state. The reset resets the circuit, and just to show that it works, action would increment the circuit. However, if we disable switch, then it doesn't work anymore, and the up increases, also increments the counter, and reset resets it. So this is the next part. Next, we need to talk about the status shifter, and what this is, it determines if it's in playback, or if it's still in recording. So we do this using a comparator and we have the current position of the circuit, and as we can see, the status is currently 1 because it's in playback, and it stays in playback until it's reset because there's a loop that makes sure that it's always in playback. And just to demonstrate this, let's say I reset it, and currently I increment the counter to 3. Now with the next rise and fall of the so usually when I'm pressing the action, I'll get to the 5th click, which gives me a value of 5. So if I get to 5, then I get the equal, and it goes in with the next clock cycle. With the next clock cycle, now it's 1, and no matter how it changes during playback, it's not going to affect the fact that it's in playback. The only way we can get out of playback status is if we click reset. Now the final thing to look at is a position shifter, and what this is it determines whether we need during playback, if we need to set the playback position back to 0 or increment it up. So we'll go 0, 1, 2, 3, 0, 1, 2, 3. And as we can see here, it's going 0, 1, 2, 3, 0, 1, 2, 3. And this is achieved using a double comparator circuit that detects if we hit a certain level before it chooses to reset or increment. And the reason we have a double AND gate here with the NOT from one going into the other is just to prevent both of them from firing at the same time, which is just a security feature. So this is the circuit, and let's reset the simulation. Now let's say I give a pH signal, so now it's 1, 2, and I click action. Now in register I should find that there's a 2 in here, which there is, and now you can see that there's a 2 here right now just because I'm recording in that position. So if I go back and I increment by 1 and go back to the register file, I can see that this is 3. So if I click the action button 2 more times, now it's 4 times that I clicked it. The 5th time we should see that the status goes to 1. Now you can see status goes to 1, action doesn't do anything anymore, and well, over here we can see that it's trying to give out steps because it's currently at 2 and it's trying to get to 3 and it's not able to get there, but we can see that the circuit is working. What we can also do to check if the circuit is working is click reset. If I go to the register file, everything is resetted. If I go to the position counter, it should also be resetted. 0. So everything is pretty much resetted. Now what I can do is, let's say I assign a value of 0 to all these 4 desired positions. So I'm clicking just action. Now the 5th time should get status. Oh, need to turn off the reset first. But 1, 2, 3, 4, 5. Resetting simulation. So click action 1, 2, 3, 4, 5. Now status is on. That means the circuit is cycling. We can see that no steps or direction signals are giving out, and the register file should have all zeros because we just didn't move the arm at all. It does have all zeros. We go back, we can see that the position counter is going from 0, 1, 2, 3, 0, 1, 2, 3, and doing all that. We can also look at the status shifter, and we'll see that it's permanently in 1. We can also look at the movement controller and see that it's just giving next signals. It's not trying to give out any steps or anything because the position and target are the same. And yeah, that's pretty much it. Thank you.